Okay, so cardiac cycle, that requires some explanation. So what is cardiac cycle? All events that happen in the heart, blood flow, opening and closing of valves, electrical events, all of this is merged in the cardiac cycle. Does that make sense? Does it make sense? So, before we start, I have a question for you. So, do you understand how valves work? Valve is a one-way street, right? Valve allows fluid, in our case, in the heart, blood, to move in one direction, but not in another direction. Does that make sense? In the heart, what opens and closes valves? But what does it? Do you want a hint?
It's like the chordinae tendineae or something? Chordate the blood?
The pressure, right? The pressure. You always have to remember that when we talk about blood, when we talk about valves, whether a valve is open or closed, it entirely depends on the pressure. Are we clear? So we're going to start with the first step of the cardiac cycle, when atria are depolarized. Are not polarized. The ventricles are not polarized, which means they both are relaxed. Does that make sense? Both atria and ventricles are relaxed. And by the way, cardiac cycle occurs simultaneously on the left and the right side of the heart. So all the events happening at the same time. Okay? Does that make sense so far? So blood flows into the atria and ventricles. Now, when blood, I have to show it. So think of it this way. Look at me. You have an atrium, you have ventricle, they're completely relaxed, and blood goes into the atrium and directly into the ventricle, because valves are open. We'll get to this. Does that make sense? So first, where does it flow from? If it's right atrium, where does the blood flowing from? So if we're talking about the right atrium, it goes from vena cava, right? If we talk about left atrium, it goes from pulmonary artery, pulmonary veins, pulmonary veins, okay? So vena cava is going to be right atrium, or pulmonary veins. It's going to be left atrium. Okay? Now what about valves? Atrioventricular valves which is going to be tricuspid and mitral valve, right? So listen, I just told you that the blood flows from the vena cava, for example, into the right atrium and then immediately into the right ventricle. Are you following me? Which means valves are open. So they are open. Now at this point, blood cannot enter the great vessels. Blood, look, blood can't enter pulmonary trunk or aorta. Why? Because semilunar valves which is going to be pulmonary and aortic valve, they are closed. And remember what we were talking about. What closes and opens valves? Pressure. So now, take a look at this. So I'm going to tell you this, look. This valve that is gone here in this scheme of things, this one, the mitral valve is open, right? The valve between the atrium and the ventricle so the blood can flow through. But the valve between the ventricle and the aorta is closed. So in terms of the pressure relationships, so you have three pressures, really. You have atrial pressure, right? You have ventricular pressure, and you have pressure in the great vessel, whether it's aorta or pulmonary trunk. So what are the relationships? Remember, at this point, listen, at this point, blood flows from the atrium into the ventricle, but it doesn't flow into the great vessel. So the valve here is open, the valve here is closed. So which of these two pressures is higher? The atrial pressure is higher. Which of these two pressures is higher? Can fluid go against the pressure? Which means?
So the great vessels are larger?
Yes. So this process here is called the ventricular filling. Okay? Does that make sense? This is called ventricular filling. During this process, heart, we call it in a diastole. Okay? Does that make sense so far? Good? Questions so far? It's pretty detailed. We got it here, pretty detailed. So now we're going to move on to atrial systole. Okay? So what happens here? For a contraction, atrium is depolarized. Does that make sense? Depolarized, it contracts. On EKG, what is going to mark this moment? Atrial depolarization. P wave, yes. So P wave signals about this. Okay, now, the purpose of atrial systole, really, is to squeeze the last little bits of blood that is in the atrium into the ventricle. Does that make sense? So, in this case, look, the situation with valves is still the same. Am I clear? But the blood is being pushed into the ventricle. Now listen closely. At this moment, when blood is being, last drops of blood, so to say, are being pushed from the atrium into the ventricle during the atrial systole, the volume of blood at the end of atrial systole, when all possible blood is squeezed into the ventricle, all of it, this is called end diastolic volume. Because generally, the terms systole and diastole, okay, systole contraction and diastole is relaxation, they usually used for describing ventricles. Does that make sense? Good?
So end diastolic volume is the volume of blood that's squeezed into the ventricles?
That is squeezed into the ventricles at the very, very end of atrial systole, or at the very, very end of ventricular diastole, because ventricles are still chill, they still relaxed. Does that make sense? So this is what happens. Okay. So look, this is an atrium. This is the ventricle. This is their position during the ventricular filling. This is their position during atrial systole. Ventricles are still relaxed.
So end diastolic volume isn't the volume of blood that occurs during ventricular filling, it's just what happens after atrial.
After atrial contract, yes, when every possible bit of blood is in the ventricle. Does that make sense? One of the biggest challenges in both explaining and understanding cardiac cycle honestly is that the process is fluid and continuous. Does that make sense? But we try to break it down into definitive steps, which is insanely hard. Okay? So as the blood goes into the ventricle, I'm going to add some in the ventricle. So when the blood goes into the ventricle, what happens to the ventricular pressure?
Increases.
It increases. But it also massively increases because at this point, under ventricular systole, we're going to have two steps. So ventricular systole starts. So ventricular systole, the ventricle is depolarized, right? Contracts. How is it reflected on the EKG? QRS complex, yes. Now remember what happened. Look, we've got all the blood in the ventricle. The pressure in the ventricle started to go up. And ventricle started to contract. As ventricle contracts, what happens to the ventricular pressure? It goes up, yeah. It increases. And look at this. Look, as ventricular pressure increases, it becomes greater than atrial pressure. Does that make sense? At some point. Okay? However, look, it's not high enough to be greater than pressure in the great vessels. Does that make sense to you? at this point, what happens to the valves?
The tricuspid and bicuspid close.
Yeah, they close. What happens to semilunar?
They stay closed.
They stay closed. So all the valves are closed. Does that make sense? Are you following me on this one? You good? So at this point, the pressure relationships are such that all the valves, semilunar valves, atrioventricular valves, they all are closed. Am I clear? When all the valves are closed, can the volume of blood that is in the ventricle, can it change? I should say, yeah, good? No. So the volume, there's no blood going in or going out. Does that make sense? This is why this stage here, we call it isovolumetric contraction phase. Okay? Does that make sense? Good? Now, at some point, the pressure in the ventricle, sorry, I need to correct myself a little bit. Remember, everything that's going to be under this, everything is going to relate to ventricular systole. Ventricle is contracting actively. So while it is contracting, ventricular pressure rises even farther. Does that make sense? It just keeps going. Like we recorded some position in the middle. So ventricular pressure is still greater than the atrial pressure, right? But now it becomes greater than the pressure in the great vessels.
This is at the end of ventricular.
Yes, this is at, so to say, at the peak, if there is a peak. Because look, this is something that I personally struggle with in terms of, we break it down into steps. But this is really a continuous process. Ventricles just squeeze and the pressure starts to rise. During certain time when we have these pressure relationships, check this out, these pressure relationships, we are in isovolumetric contraction phase, right? The moment ventricular pressure becomes the highest, what happens to semilunar? They open. So what happens to atrioventricular valves? They stay closed. Does that make sense? So blood, at this point, look, at this point, blood that's in the ventricle, it can't go back. And the only route it can take is to get into the great vessel. Does that make sense? So it gets into the great vessel, we call it an ejection phase. I have a question. When ventricles squeeze the blood out, do they squeeze all of it? Come on, it's a question like a hint. Like what should be an answer? Do they squeeze all of it? No. So some of the blood is left in a ventricle at the end of ejection phase. Does that make sense? Some of the blood is left in the ventricle, listen closely, at the end of ventricular systole. So what do you think will be the name for that volume? At the end of ventricular systole, the amount of blood that's left in the ventricle is called end systolic volume. Okay? Does that make sense? Now, next we go into ventricle. Oh, by the way, at this point, just FYI, look. So, oh yeah. So, at this point, by the way, atrium is relaxed. Like it relaxes somewhere around like here. Atrium relaxation goes on. We just don't pay attention to it because it's like not really super important. So far so good? So that brings us to the moment when systole is completed and ventricle starts to relax. Okay? So it's going to be the start of ventricular diastole. So what happens during ventricular diastole? Ventricle is repolarizing, relaxing. Does that make sense? So as ventricle, look at my fist, that's ventricle. As ventricle relaxing, what happens to the volume in the ventricle? Well, the size of the ventricle increases, right? And when you have same amount of blood occupying a bigger and bigger volume, what happens to the pressure when ventricle relaxing? Pressure goes down, right? Ventricular pressure decreases. And compare this relationship over here to the relationship that we're going to have now. When ventricle is actively relaxing, the pressure in the ventricle, while still being higher than the pressure in the relaxed atrium, see that? It becomes smaller than the pressure in the great vessel. On top of that, think of it this way. We pushed a shit ton of blood in the great vessel, which immediately produced a spike in pressure in the great vessel, right? So the pressure in the great vessel becomes high, the pressure in the ventricle becomes, well, lower, and we enter. So what happens to semilunar valves? They close. Atrioventricular close. Is closed. So guess what? This is called isovolumetric relaxation. Does that make sense? Now, look what happens next. Ventricle still relaxes. It keeps relaxing. It keeps relaxing. And the pressure in the ventricle drops and drops and drops until eventually we get to the square one, ventricular filling. Does that make sense? And the whole process starts again. Does that make sense? I'm going to run through it one more time. So, again, in the very beginning, I know that saying about cycle at the very beginning is kind of, not correct. But the very beginning, everything is relaxed, right? Everything is not depolarized, no polarization there. Blood freely flows through the atria, through the open atrioventricular valve, whatever it is, depending on the side, into the ventricle, okay? It flows from the vena cava, if it's the right side, from pulmonary veins, if it's the left side. So blood flows, it feels the ventricles, and then during atrial contraction, atrial systole, atrium is depolarized, that's P wave. So SA node, P wave. So atria, they contract, they push the rest of the blood into the ventricles, and that results in end diastolic volume in the ventricle. Okay, we're good. In diastolic volume, I have a brain fart right now. Okay, I'll try to overcome this. So ventricle starts to contract. That's the start of ventricular systole. That's the curious complex. You know, the volume kind of decreases, pressure in the ventricle goes up, becomes higher than the pressure in the atria, right? When it becomes higher than the pressure in the atria, all valves close. So I have this picture here. So the volume of blood does not change. Contraction, isovolumetric contraction phase. Contraction keeps going. At some point, when contraction is maximum, the pressure in the ventricle is so high that it becomes bigger than both in atria and in the great vessels, which means atrioventricular valves remain closed, but semilunar are open. And blood is being ejected, ejection phase, into pulmonary trunk if it's the right side, aorta if it's the left side. At the end of systole, ventricular systole, the blood that's left in the ventricle, we call it end systolic volume, right? So the blood that's left in the ventricle starts to relax. And on top of that, blood is being pushed to great vessels. So pressure in the great vessel in the vicinity to the valve also goes up. So this goes up, this goes down. At some point, the relationships between the pressures will be that all valves are going to be closed during relaxation. We call it isovolumetric relaxation. When ventricle is completely relaxed, so basically somewhere here we have a T wave. T wave, right? When ventricle is completely relaxed, we go back to square one, to the start of ventricular filling. That makes sense? The sounds of the heart that you hear, one of them is first sound, closure of the atrioventricular valves, and second sound during in the beginning of isovolumetric relaxation. That makes sense? So when you listen to the heart, the sounds are not from opening, they're from closing. Does that make sense? Questions? Basically, I can tell you, like if you can lay out cardiac cycle on a piece of paper, that's a good chunk of questions. Maybe half the questions in the exam, one way or another, relate to cardiac cycle. I'm telling you, this unit is very, how to say, very schematic.